This program, DFTSUM, demonstrates that a real sequence x of n of length n can be expressed as the sum of n over 2 cosines with frequencies that are multiples of 2 pi over n plus a DC term. You enter a finite length real sequence x of n in this box on the top left. The length of the sequence n is determined by the edit box on the top right, and the allowed values of n are limited to even numbers up to 16. If the number you enter for the sequence is of length greater than n, it is truncated to n. If the length of the sequence is smaller than n, zeros will be appended. You can also adjust the values of the sequence by dragging directly in the panel here. The lower panels show the magnitude and phase of the DFT in n solid symbols, and clicking the color control here puts these dots in color. Values of the DFT that are complex conjugates of each other are shown in the same color. The panels on the right side of the figure show the cosine terms. Each term, k is equal to 0, 1, 2, 3, through k is equal to n over 2, in this case 4, has frequency 2 pi k over n. So k equals 0 is the DC term, k is equal to 1 cycle of the cosine and endpoints, and so on. The k is equal to n over 2 term has a frequency of pi. The magnitude and phase of each of these cosine terms is equal to the magnitude and phase of the corresponding colored point in the DFT. So for example, the k is equal to 2 term has a magnitude of 1 and a phase of minus pi over 2, and is therefore a sine. Click on this button to show an extra point in the DFT that corresponds to 2 pi. This also appends a point to the end of each of the cosine plots, which can help better show the periodicity of the cosines. Click on this point to scale all the cosines by the appropriate amount and add them together to form x of n, given in the bottom panel here. You can shift the sequence circularly modulo n by dragging in the display here. Of course, the phase of all of the cosine terms changes as well. This program is one of a suite of programs that I have developed to explain DSP concepts to my students during lectures. There are now well over 24 programs covering many aspects of the material in the book, including complex exponentials and sinusoids, convolution, the DTFT, pole zero plots and their relation to frequency and impulse response, A to D and D to A conversion, including upsampling, downsampling, resampling, and aliasing, the design of many types of FIR filters and their application to the filtering of speech and other signals, the design of IIR filters, circular shift and convolution using the DFT, the discrete cosine transform, and the short-time Fourier transform. A selection of these programs is being made available to instructors who are currently adopting the book in their classrooms. For further information, please visit cambridge.org/Holton.